Hey guys, how's it going? Guys, have a lot of fun last night? Ezio, what's up? Laser, you guys are back. For an XM4 loadout. What is this? I still I still have this Ryzen 9 on my desk. Hopefully we can start getting close next week. But that's old tech now. We're interested in the new tech. I think this I think this keynote's gonna run about 90 minutes, give or take. That's what it's estimated for. How you doing, Roger? Finally gave in first. Dang it. Nah, there were a few before you. But you were close. You were close. What do you guys think they're going to announce? Do you think that they're going to announce the I'm pretty sure they're going to announce the 5080, the 5090. Uh but I'm not I don't think they're going to be 5090 is going to be $2500 calling it. It just might be. I mean, like, on that tier of performance, NVIDIA has no competition. They have no competition. And right now they are definitely they're hungry for money. Developing AI takes a lot of money, and right now they're heavily relying on the stockholders that are like pouring all the money into them. So stockholders want high prices. That's probably what they're gonna do. Your stream is frozen? Oh no. Try and refresh the browser. Seems fine on your end, right? Assistant says it's fine on his end. All right, witness protection. What do you think is what do you think's gonna be the price of the 5080? The updated AMD naming scheme. I mean, it's gonna confuse quite a few people by like 2030, 2031. But I think that they'll be able to know the difference. I'm talking with like NVIDIA's cards and stuff like that. But to have like, I think what their mobile GPUs are the 8000 series, and their desktop grade is 9000 now. I mean, like, I think doing it that way is pretty good. NVIDIA did that like once, and I don't know, they just never went back. So you can't wait to get your hands on a 9950 X3D. That's gonna be pricey. You building a high end build, you're gonna throw a 5080 in it or something. Assistant face reveal when? I don't know. It's I feel like that's part of the gag. You guys don't know what he looks like. Custom loop. Okay, all right. You're going all the way. You're going all the way. Yo, Prince, how's it going? How's it going? Welcome to the stream. This one should be, pretty chill, pretty laid back. Just just seeing what's going on in this keynote. Maybe we'll have some takes, see how it goes. Uh I will say that if this ends up selling out or being like a paper launch, um Nvidia will probably crank the prices up for the 6000 series. And then like everything will get really unaffordable by then. You're thinking 7'2" with blonde hair and blue eyes. Well, I don't know about that. If they were that tall, they'd probably be in the NBA. But instead, they're assisting this lame guy right now. Let's see. All right, Nvidia's got some cheesy music playing for now. Another what? Probably 8.5 minutes before they start the keynote. Oh, you're doing one final build before you buy a house. Congrats on that. Got to get something to last 10 years? Well, if it's on the AM5 platform, then you'll have all the upgrades you'll need. You probably won't need to do anything to that motherboard for a while. That's going to be a crazy build, though. You got to send me a pic of that. And then also, you got to put, you're going to have to put a RamTech SSD in there. If there's not a RamTech SSD in there, I'm going to be pretty disappointed. No, I'm just joking. Choose what you want, but I'm telling you right now that we got the good stuff. When the 4 terabyte comes out, you're getting one? Okay, sounds good. Sounds good. All right, so let's see here. And then also, guys, I am thinking that the next Sunday Fun Day will be next Sunday. I was talking about how it might have to be pushed, back to the Sunday after, or we can pull it back to like Saturday. I think it's going to be on Sunday. Are you into competitive programming? I am not. I am not. Um, Programming isn't my strong suit. It's more with hardware. I accidentally sent it here too. But yeah, no, I'm not into that kind of competitiveness. What about Mad Day Monday or Technology Tuesday? Hmm. Yeah, we might do that, something like that. That's those are some good ideas right there, Roger. On the 5090 price, I know that it's been a lot of back and forth because there have been like apparent leaks from meetings that NVIDIA was saying 2000 to 2500, and then they were talking about 2500, and then I guess there was some backlash and it was pulled back, but then rumors state in a later meeting it was pushed forward. I don't know. But I think witness protection is probably right. I think that right now NVIDIA is trying to push as fast as possible to develop AI. Uh, and right now they're very stockholder dependent, and stockholders, they want, they're pretty much going to want as much money as possible. The competition is basically non existent at that level. Very possible that they just go with 2500. Nvidia stock was up a ton. Yeah, no, that's what I'm saying. Uh, Apple is up a lot. Nvidia is up a lot. They're both nearing 4 trillion. Let me see what NVIDIA stock is. All right, all right. Yep, good amount today. They literally jumped like 3.5%, 4%. All right, moment is just around the corner. We got 3 minutes till it starts. Roger, I wish it was 0. But it would be sold out so fast, like you wouldn't believe it. The 7000 series, insane price to performance. Yeah, it is insane price to performance. But that's just in regular rasterized gaming. Uh, NVIDIA and many other areas, they're just better. Like I know that we don't care about ray tracing all that much, but pretty soon here, ray tracing is just gonna become the standard. Like you can't deny that games just look so good when they're ray traced. They um have not said anything yet. Next RAM Tech giveaway is a 5090. I mean, if you can even get your hands on one. When is the keynote? The keynote starts in about 2 minutes. I'll tell you right now, you guys, is that I don't know what's going to happen as far as stock when this drops. But I'll tell you right now that in the next day or two, there's going to be like, if you want to get a 4090 for cheap, then I'd say buy it tomorrow or the day after. Unless they obviously skyrocket the price to something ridiculous, uh, then it's gonna have like next to no effect. But if it's like the 30 series where it's like, oh, okay, the 3080 is $700 and it's that much better than the 2080 Ti. You saw 2080 Ti's drop like 66% in price like overnight, only to jump back up to like their original price when there's like nothing in stock. All right. So it should be any moment now. Is that a good audio for you guys? All right, cool. Play King Von, please. Tonight is just the keynote. Yes. I don't know if we're gonna be doing anything else afterwards. Probably not, but we'll see. I don't know. Go ahead and full screen this. The Y is outrageous. All right. Should be like any moment. You're gonna make a travel PC? That'd be pretty sick. Yeah, that's kind of like why I would like to dabble in like small form factor and stuff. $2080 Super in it? Yeah. What's it called? Assistant has a small form factor PC. It's got a 2080 Super in it as well. I got it a while ago. You hear the background. There's some lady that was like, "Oh my god, this is gonna be amazing," and then NVIDIA is gonna be like $3,000 for the 5090, and she's like, "That is not amazing." Oh, you just put it into your pre-built. I feel that. I swear, if it's 1K for the 5070, yeah, I know. That would be wild. Did AMD announce anything yet? No, not yet. Alright, NVIDIA's taking their sweet time. Guess they gotta build up the anticipation. Yeah, I wonder when AMD is gonna be doing their segment. Yo, a GTX 1060. Oh, that's an old i5, man. Do I have any recommendations that I should probably... That, I mean, number one thing, you gotta get a new motherboard, you gotta get a new CPU, for sure.
CES isn't just about what's next. It's about what's possible. And when technology and humanity intersect, the answer is anything. That's because tech doesn't just solve challenges. It transforms them into opportunities. It helps us move smarter, live healthier, and experience the world in ways we never thought possible. We are not just here for a tech event. We're here to connect, to solve, to discover, together.
Ezio, do you build a lot of PCs for like people and stuff?
It's uniting, bringing us closer to an autonomous future, connecting us to better care, making life more connected, more dynamic, and more human. Today's challenges demand bold solutions, and CES is where they start to take shape.
And sold some,
Breakthroughs
makes
in
sense.
sustainability, advancements to help feed our growing world. This week isn't just a stage for breakthroughs, it's the spark for discovery. Every screen, every pixel, every part of the tech you will see here showcases the extraordinary potential of human ingenuity meeting technological power. Now we begin this celebration of what connects us, has the power to solve our greatest challenges, and offers endless possibilities we're yet to discover. Right here, right now, the world is watching. So let's dive in.
Ladies and gentlemen, welcome to CES 2025. I'm Gary Shapiro, CEO and Vice Chairman of the Consumer Technology Association.
All right, here, let me go ahead and turn it up.
Of CES, and I am so thrilled to kick off this show with a keynote by one of the most consequential companies in the world. NVIDIA exemplifies the cutting-edge innovation
NVIDIA.
we celebrate at CES. And founder and CEO Jensen Huang is a true visionary, demonstrating the power of ideas, technology, and conviction to drive innovation and reshape our industry and our society. I always like to say that if I'd listened a little bit more closely the last time Jensen spoke at a CTA event, I could have retired already. But over the past 3 decades, he has established NVIDIA as a force driving change across the globe in industries ranging from healthcare to automotive and entertainment. Today, NVIDIA is pioneering breakthroughs in AI and accelerated computing that touch nearly every person and every business. Thanks to his leadership, NVIDIA's innovations enable advanced chatbots, robots, software-defined vehicles, huge virtual worlds, hyper-synchronized factory floors, and so much more. Huang has been named the world's best CEO by Fortune and The Economist, as well as one of Time Magazine's 100 most influential people in the world. But you know, the fact is, like for all of us in this room, our success and his success was not preordained. Jensen started out working at a Denny's
yeah.
as a dishwasher and a busboy, so be nice to them in the future. And he said that the lessons he's learned there, the value of hard work, humility, and hospitality, are what helped him keep the faith and persevere through some of NVIDIA's early challenges. In just a few minutes, we'll hear from NVIDIA founder and CEO Jensen Huang on his unwavering vision of the future and where we're headed next. Stay tuned and have a great CES.
You're constantly changing gears, Corsair 1000D. Yeah, I feel that. Have you tried Seasonic for their power supplies? They're pretty good too. You told your dad to buy NVIDIA stock just now? It'll be back and forth, but I'm sure it'll go up. Yeah, it's just too bad that EVGA is becoming like a shadow of its former self. And it really was like all of the disagreements that NVIDIA and EVGA had. And it just seems like the CEO of EVGA kind of shot himself in the foot when he pulled out a graphics cards, which is like 90% of what makes up EVGA. Yeah, I just wish he never made that decision. I understand where he's coming from, but... They looked the best, they performed the best, their customer service was the best, their tech support was the best, yeah. PNY is your go-to? PNY is honestly slept on. Like, there's a reason why, like, they're so prominent in the server space. They just don't advertise to, like, gamers or anything, but they really do have their game on point. Asus and Gigabyte? Yeah, I mean, like, they're good. I don't think... And there's a lot of areas where I think PNY is better than them, though. But again, I mean, you're talking about a gamer brand versus a non-gamer brand. Of course, like, Gigabyte and Asus are more well-known to the general public. That's who they advertise with. And, I mean, if you're talking about, like, the server space, then PNY is in there deep, like, super deep. Yeah, go ahead and DM it to me. Their software is eh. Yeah, I guess. I mean, like, I've been okay with it. PNY have RGB on their stuff? No, pass. Very few cards too. They have some that they kind of advertise to gamers, but not nearly as hard. That's not their focus. Yeah, some of them have RGB. But as far as reliability goes, I mean, PNY's ceded their spot in there. Server companies probably wouldn't really take Asus or Gigabyte or give them as big of contracts as they would PNY.
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, the first step into an extraordinary world, where endless possibilities are born. Tokens transform words into knowledge and breathe life into images. They turn ideas into videos and help us safely navigate any environment. Tokens teach robots to move like the masters. Inspire new ways to celebrate our victories.
A martini, please.
Coming right up.
Thank you, Adam.
And give us peace of mind when we need it most.
Hi, Moroka.
Hi, Anna. It's good to see you again.
Hi, Emma. We're gonna take a blood sample today, okay?
Don't worry. I'm gonna be here the whole time.
They bring meaning to numbers to help us better understand the world around us.
Is that the Quadcast 2? Quadcast 2S.
Predict the dangers that surround us. And find cures for the threats within us. Tokens can bring our visions to life. And restore what we've lost.
Zachary, I got my voice back, buddy.
They help us move forward. One small step at a time. And one giant leap. Together. And here is where it all begins.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Yep, there's the man himself.
Welcome to CES! Are you excited to be in Las Vegas? Do you like my jacket?
I was gonna say he updated his jacket.
I thought I'd go the other way Hey, from Gary Shapiro. I'm in Las Vegas after all. If this doesn't work out, if all of you object, well, just get used to it. I really think you have to let this sink in. In another hour or so, you're going to feel good about it. Well, welcome to NVIDIA. In fact, you're inside NVIDIA's digital twin. And we're going to take you to NVIDIA. Ladies and gentlemen, welcome to NVIDIA. You're inside our digital twin. Everything here is generated by AI. It has been an extraordinary journey, extraordinary year, and it started in 1993.
Ready, go!
With NV1, we wanted to build computers that can do things that normal computers couldn't.
Snakeskin jacket, crocodile jacket.
Made it possible to have a game console in your PC. Our programming architecture
Me when
was
this
called
the 5090 is
UDA.
$6,000, they
Missing
can
device
charge it
until
and no one else
a
would
little while later,
be able to
but
compete.
UDA, Unified Device Architecture. And the first developer for UDA and the first application that
Because I'll tell you, like, server companies would buy it,
Sega's
even at
Virtual
that
Fighter.
price.
6 years later,
And they do.
we invented, in 1999, the programmable GPU. And it started 20 plus years of incredible advance in this incredible processor called the GPU. It made modern computer graphics possible. And now, 30 years later, Sega's Virtual Fighter is completely cinematic. This is the new Virtual Fighter project that's coming. I just can't wait. Absolutely incredible. 6 years after that, 6 years after 1999, we invented CUDA so that we could explain or express the programmability of our GPUs to a rich set of algorithms that could benefit from it. CUDA initially was difficult to explain, and it took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012, Alex Karshevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and the rest of it is history. AI has been advancing at an incredible pace since. Started with perception AI. We now can understand images and words and sounds. To generative AI, we can generate images and text and sounds. And now, agentic AI. AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI, 2012. Now,
All right, guys,
magically,
the robot invasion's coming.
2018, something happened that was pretty incredible. Google's Transformer was released as BERT, and the world of AI really took off. Transformers, as you know, completely changed the landscape for artificial intelligence. In fact, it completely changed the landscape for computing altogether. We recognized properly that AI was not just a new application with a new business opportunity, but AI, more importantly, machine learning enabled by transformers, was going to fundamentally change how computing works. And today, computing is
Let me see my
revolutionized
GPUs.
in every single layer, from hand coding, instructions that run on CPUs to create software tools that humans use. We now have machine learning that creates and optimizes neural networks that processes on GPUs and creates artificial intelligence. Every single layer of the technology stack has been completely changed. An incredible transformation in just 12 years. Well, we can now understand information of just about any modality. Surely you've seen text and images and sounds and things like that. But not only can we understand those, we can understand amino acids, we can understand physics. We understand them, we can translate them, and generate them. The applications are just completely endless. In fact, almost any AI application that you see out there, what modality is the input that it learned from? What modality of information did it translate to? And what modality of information is it generating? If you ask these three fundamental questions, just about every single application could be inferred. And so when you see application after applications that are AI-driven, AI-native, at the core of it, this fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well, GPUs, GeForce, in a lot of ways, all of this with AI is the house that GeForce built. GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you some of it now.
Oh no, what happened? Well, seems like their YouTube stream is lagging because there might be like a bunch of people looking into it. That's unfortunate. Uh, everyone in the chat is like F. Alright guys, the realistic physics update just dropped.
That was real-time computer graphics. No computer graphics researcher, no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. There are two fundamental things that we did. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the colors should be, it has been trained on a supercomputer back in NVIDIA, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS. The latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate. What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3, if I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33. And as a result, we're able to render at incredibly high performance.
Yeah, so like if you
AI
don't,
does
if you're like
tremendous computation.
pretty much like, oh,
So
let's
of
get
course,
to the
enormous
GPUs,
amount of
AI is
training
not
to
important.
produce that.
DLSS,
Once
I
we
mean,
train
it's what's
the
gonna double
generation,
your
it's
rasterized
extremely
performance.
So this is
So
one
it
of
is
the
pretty
incredible
important.
capabilities of artificial intelligence, and that's why there's so many amazing.
And it's just
things that
getting
happen.
better and better.
We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look.
All right, here it comes, guys. 5000 series, just around the corner.
Here it is. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 tops, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops, so that we could, for the pixels that we have to compute the most beautiful.
I wonder how big that die is.
And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is
The
for
bigger it
floating
is, the
point,
more
one for
expensive
integer.
it'll be.
G7 memory from Micron, 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary
It done
results.
something weird where it's
so
like
this
the
is-
PCB is like
this is,
disconnected from the bracket.
Brand new RTX Blackwell 5090. Now, even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? Is it literally this big? The voltage regulated design is state of the art.
Yeah, that thing's puny.
Incredible design. The engineering team did a great job. So here it is.
I think because of all the cards that were getting killed by certain sagging, maybe that's why they've
Okay, so
done the
those are
design they
speeds
did.
and feeds, so how does it compare? Well, this is RTX 4090. I know many of you have one. I know it. Look, it's $1,599.
Oh, here we go.
It's one of the best investments you could possibly make. For $1,599, you bring it home to your $10,000 PC entertainment command center. Isn't that right? Don't tell me that's not true. Don't be ashamed. It's liquid cooled. Fancy lights all over it. You lock it when you leave. It's the modern home theater. It makes perfect sense. And now for $1,500 and $1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070,
Okay.
4090 performance at $549.
Watch. 4090s are now gonna drop to like literally like 500, $400 or $500 on eBay, probably like tomorrow. That's gonna happen. I'm pretty sure.
Impossible without.
So I would recommend you buy one now on eBay if you get the chance.
Tensor cores. Impossible without the G7 memories.
Yeah.
Okay, so
No.
5070.
We've seen this before.
$549, and here's the whole family. Starting from 5070 all the way up to 5090.
Okay, 2000.
Twice the performance of a 4090. Starting, of course, we're producing at very large scale, availability starting January. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1,299, this 5070 laptop has a 4090 performance. I think there's one here somewhere. Let me show you this. This is a
$2,000.
Here, here. There's only so many pockets. Ladies and gentlemen, Janine Paul. So can you imagine? You get this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense? Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate using artificial intelligence all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing is, oh, here we go. Thank you. This is a surprisingly kinetic keynote. and what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. Okay, so ladies and gentlemen, the RTX Blackwell family.
Go ahead and pull it back up over here.
Well, GeForce brought AI to the world, democratized AI. Now AI has come back and revolutionized GeForce. Let's talk about artificial intelligence. Let's go to somewhere else at NVIDIA. This is literally our office. This is literally NVIDIA's headquarters. Okay, so let's talk about AI. The industry is chasing and racing to scale artificial intelligence. And the scaling law is a powerful model. It's an empirical law that has been observed and demonstrated by researchers and industry over several generations. And the scaling law says that the more data you have, the training data that you have, the larger model that you have, and the more compute that you apply to it, therefore, the more effective or the more capable.
Okay, guys, so real quick, here's the pricing. 5070 is $550.
What's really amazing,
the 5070 Ti is $750. The 5080 is $1,000, and the 5090 is $2,000.
In the next couple of years, humanity will produce more data.
Red Cat, you don't know if you should still get a 4090? I'm going to tell you right now that the prices for the 4090, because people are watching this, they're gonna be selling out of fear. they're going to be
sound.
dumping their cards
All
for
of that
cheap.
data could be used
Uh,
to train
I think that this will
fundamental
probably
knowledge,
sell out,
foundational
to be
knowledge of
honest.
an AI. But there, in fact,
And then the
two
prices of
other
the
scaling
4090
laws
will shoot
that has
right
now
back up.
emerged. And
So
it's somewhat intuitive.
after this keynote would be the
Second
best
scaling
time
law
to buy
is
a 4090.
Post-training scaling law. Post-training scaling law uses technologies, techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers based on a human query. The human then, of course, gives a feedback. It's much more complicated than that, but that reinforcement learning system with a fair number of very high-quality prompts causes the AI to refine its skills. It could fine-tune its skills for particular domains. It could be better at solving math problems, better at reasoning, so on and so forth. And so it's essentially like having a mentor or having a coach give you feedback after you're
How much
done
was the
going to school.
4090? 4090 was
So you test,
$1,600.
feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data generation. These techniques are rather
The 5070 is going to be the equivalent of the 4090,
if you will,
but it's going to
but
pull
some
less
practice.
power, so
You
it'll be
know-
like more
you know the
efficient
answer to a particular
for
problem,
550
and,
bucks.
you
So
continue to
you can
try it until
expect
you get it right.
that it's
So
possible
if you like
4090s are going to be
system
going for
with a
less than
very complicated,
$500
difficult
potentially
problem
on
that
eBay.
is verifiable functionally.
And Red Cat, eBay is going to be your
So
best
we
shot,
understand
to be
proving
honest.
a theorem,
It's going to be your best shot.
solving a geometry problem. And so these problems would cause the AI to produce answers, and using reinforcement learning, it would learn how to improve itself. That's called post-training. Post-training requires an enormous amount of computation, but the end result produces incredible models. We now have a third scaling law, and this third scaling law has to do with what's called test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation to use to produce the answers it wants to produce. Reasoning is a way of thinking about this. Long thinking is a way to think about this. Instead of a direct inference or one-shot answer, you might reason about it. You might break down the problem into multiple steps. You might generate multiple ideas and evaluate, your AI system would evaluate which one of the ideas that you generated was the best one. Maybe it solves the problem step by step, so on and so forth. And so now test time scaling has proven to be incredibly effective. You're watching this sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3, and now Gemini Pro. All of these systems are going through this journey step by step by step.
5090 is $2,000.
Training to test time scaling. Well, the amount of computation that we need, of course, is incredible. And we would like, in fact, that society has the ability to scale the amount of computation to produce more and more novel and better intelligence. Intelligence, of course, is the most valuable asset that we have, and it can be applied to solve a lot of very challenging problems. And so, scaling law. It's driving enormous demand for NVIDIA computing. It's driving enormous demand for this incredible chip we call Blackwell. Let's take a look at Blackwell. Well, Blackwell is in full production. It is incredible what it looks like. So first of all, there's some, every single cloud service provider now have systems up and running. We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations. They're liquid-cooled, air-cooled, x86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation. And it's very clear that
Yeah, but 8K monitors have diminishing returns. I think 4K is really as far as you would want to go, depending on the size of your monitor.
you know, it's hard to tell. You don't ever want to reach your hands into a dark place.
And that's why like Apple has not like made higher density screens on their like iPhones and stuff, is because there's a diminishing return.
Wait for it. Wait for it. I thought I was worthy. Apparently, Yonir didn't think I was worthy. All right. This is my show and tell. This is a show and tell. So, this NVLink system, this right here, this NVLink system, this is GB200 NVLink 72. It is 1.5 tons, 600,000 parts, approximately equal to 20 cars, 120 kilowatts. It has a spine behind it that connects all of these GPUs.
Because why would they sell it for $500?
2 miles of copper cable.
The
5,000.
there might be back and forth. It's probably going to be roughly around there.
45 factories around the world.
It probably will be around 4090 performance. It sounds right. The thing is that I'm pretty sure they're going to have limited production.
The data centers and install them. The manufacturing is insane. But the goal of all of this is because the scaling laws are driving computing so hard that this level of computation, Blackwell...
I'll get more into it like after the keynote, but just kind of focusing on this at the moment.
Performance per watt by a factor of 4, performance per dollar...
Drink every time Jensen says AI,
basically says,
I would have to go to the hospital.
We reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost. But the important thing is this. These are generating tokens that are being used by all of us when we use ChatGPT or when we use Gemini, use our phones in the future. Just about all of these applications are going to be consuming these AI tokens. And these AI tokens are being generated by these systems. And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that could be generated, the amount of business that can be generated in the data center is increased by a factor of 4. And so these AI factory systems really are factories today. Now the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible. And this is basically one giant chip. If we would have had to build a chip, here we go. Sorry, guys. You see that? That's cool. Look at that, disco lights in here. If we had to build this as one chip, obviously this would be the size of the wafer, but this doesn't include the impact of yield. It would have to be probably 3 or 4 times this size. But what we basically have here is 72 Blackwell GPUs or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips, okay? And we have 130 trillion transistors in total. 2,592 CPU cores, whole bunch of networking. And so these, I wish I could do this. I don't think I will. So these are the Blackwells. These are our ConnectX networking chips. These are the NVLink, and we're trying to pretend about the NVLink spine, but that's not possible, okay? And these are all of the HBM memories, 14 terabytes of HBM memory. This is what we're trying to do, and this is the miracle. This is the miracle of the Blackwell system.
Dude, Micron's probably making
Right
bank.
It is the largest single chip the world's ever made.
Like, this stuff
But
needs
yet,
so much
the
RAM.
miracle is really, in addition to that, this is the Grace Blackwell system. Well, the goal of all of this, of course, is so that we can, thank you, thanks. Boy, is there a chair I could sit down for a second? Can I have a Michelob Ultra? How is it possible that we're in the Michelob Ultra Stadium? It's like coming to NVIDIA and we don't have a GPU for you. So we need an enormous amount of computation because we want to train larger and larger models, and these inferences used to be one inference, but in the future, the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting, processing. So today, when the tokens are being generated at you, so long as it's coming out at 20 or 30 tokens per second, it's basically as fast as anybody can read. However, in the future, and right now with GPT-01, you know, with the new Gemini Pro and the new the 01, 03 models, they're talking to themselves, reflecting, they're thinking. And so, as you can imagine, the rate at which the tokens could be ingested is incredibly high. And so we need the token rates, the token generation rates, to go way up. And we also have to drive the cost way down simultaneously so that the quality of service can be extraordinary, the cost to customers can continue to be low, and AI will continue to scale. And so that's the fundamental purpose, the reason why we created NVLink. Well, one of the most important things that's happening in the world of enterprise is agentic AI. Agentic AI basically is a perfect example of test time scaling. AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage, a semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file.
Well, they say when it releases, they said January, so I'm sure they'll give a date, like a specific date later on.
And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background. And so test time scaling, the amount of computation used for inferencing, is going to go through the roof. It's going to go through the roof because we want better and better answers. Well, to help the industry build agentic AI, our go-to-market is not direct to enterprise customers. Our go-to-market is we work with software developers in the IT ecosystem to integrate our technology to make possible new capabilities, just like we did with CUDA libraries. We now want to do that with AI libraries. And just as the computing model of the past has APIs that are doing computer graphics or doing linear algebra or doing fluid dynamics, in the future, on top of those acceleration libraries, CUDA acceleration libraries, we'll have AI libraries. We've created 3 things for helping the ecosystem build agentic AI. NVIDIA NIMs, which are essentially AI microservices all packaged up. It takes all of this really complicated CUDA software, CUDA DNN, Cutlass, or TensorRT-LM, or Triton, or all of these different really complicated software, and the model itself. we package it up, we optimize it, we put it into a container, and you could take it wherever you like. And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models coming for physical AI. And these AI models run in every single cloud because NVIDIA's GPUs are now available in every single cloud. It's available in every single OEM. So you could literally take these models, integrate it into your software packages, create AI agents that run on Cadence, or there might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run the software. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding.
Time to sell some
and
GPUs.
training
I'd be careful about doing
evaluation
that.
In the future, these AI agents are essentially digital workforce that are working alongside your employees,
I'll go into more details about that after the keynote,
and so the way that you
but
would,
I think
bring
it'll be
these
difficult.
specialized agents into these special agents into your company is to onboard them, just like you onboard an employee. And so we have different libraries that helps these AI agents be trained for the type of language in your company. Maybe the vocabulary is unique to your company. The business process is different. The way you work is different. So you would give them examples of what the work product should look like. And they would try to generate it, and you would give a feedback. And then you would evaluate them, so on and so forth. And so that, and you would guardrail them. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say. And we even give them access to certain information. Okay, so that entire pipeline, digital employee pipeline, is called NeMo. In a lot of ways, the IT department of every company is going to be the HR department of AI agents in the future. Today, they manage and maintain a bunch of software from the IT industry. In the future, they'll maintain, nurture, onboard, and improve.
Yo, AK Rep General, thank you for the subscription, man. Appreciate that Prime.
Okay, and so your IT department is going to become kind of like AI agent HR. And on top of that,
Make sure to show up to the next giveaway so that we could do, you can get your Put Me in Coach emote.
This is completely open source.
Put it to good use.
Take it. And
2 more subs until goal, guys. 2 more
blueprints for all these
subs.
different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the NVIDIA Llama Nemotron language foundation models. Llama 3.1 is a complete phenomenon. The download of Llama 3.1 from Meta, 650,000 times, something like that. It has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about every single enterprise.
You fell asleep. Did I miss anything important? Just like the whole 5000 series. I don't know when you fell asleep.
That the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. There are small ones that interact in very, very fast response time, extremely small. They're what we call super Llama Nemotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not. Basically give feedback to other models. It could be distilled in a lot of different ways. Basically, a teacher model, a knowledge distillation model. Very large, very capable. And so all of this is now available online. Well, these models are incredible. It's number 1 in leaderboards for chat, leaderboard for instruction, leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you. We're also working with the ecosystem. All of our NVIDIA AI technologies are integrated into the IT industry We have great partners and really great work being done at ServiceNow, at SAP, at Siemens for industrial AI. Cadence is doing great work. Synopsys is doing great work. I'm really proud of the work that we do with Perplexity. As you know, they revolutionized search. Yeah, really fantastic stuff. Codium, every software engineer in the world. This is going to be the next giant AI application. Next giant AI service, period, is software coding. 30 million software engineers.
Something I'm wondering is for the
going to have a software assistant.
what
Helping
a
them
big
code.
part of what's going to be important is how much
non-obvious
RAM is in
it's
each
gonna
one
be
of these. They haven't
way
announced
less
how much
productive
RAM is going to be in
listen
each
to code.
GPU just
And
yet.
so this is 30 million.
And I'll get into
Billion
why that's important.
knowledge workers in the world. It is very, very clear AI agents is probably the next robotics industry and likely to be a multi-trillion-dollar opportunity. Well, let me show you some of the blueprints that we've created and some of the work that we've done with our partners with these AI agents. AI agents are the new digital workforce, working for and with us. AI agents are a system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. NVIDIA's agentic AI building blocks, NIM pre-trained models, and NeMo framework let organizations easily develop AI agents and deploy them anywhere. We will onboard and train our agentic workforces on our company's methods, like we do for employees. AI agents are domain-specific task experts. Let me show you 4 examples. For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results, and generate interactive podcasts for easy learning.
By combining a UNet model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers, like at NVIDIA, manage software security AI agents that continuously scan software for vulnerabilities, alerting developers to what action is needed. Virtual Lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever. And Video Analytics AI agents built on an NVIDIA Metropolis blueprint, including NVIDIA Cosmos Nematron vision language models, Llama Nematron LLMs, and NeMo Retriever. Metropolis agents analyze content from the billions of cameras generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting, and help monitor traffic flows, flagging congestion or danger. In industrial facilities, they monitor processes and generate recommendations or improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here for every organization.
I don't know if it would be better than like double the RAM. We'd have to see some performance numbers.
That was the first pitch at a baseball game. That was not generated. I just felt that none of you were impressed. Okay, so AI was created in the cloud and for the cloud. AI was created in the cloud for the cloud. And for enjoying AI on phones, of course, it's perfect.
I don't think it's going to be
Very,
that
very
much.
soon, we're gonna
Probably
have
like 32
continuous
gigs
AI
for the
that's
5090.
going to be with you. And when you use those Meta glasses, you could, of course, point at something, look at something, and ask it, whatever information you want. And so AI is perfect in the cloud. It was created in the cloud. It's perfect in the cloud. However, we would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud.
It will probably
and you
still
could
be a
also
little
put it
bit
inside your
better. I
company.
mean, that
But
could
the thing that we
probably
wanna
be the
do is
case. I
we
think
need
they
to
said
put
the
on
same thing for the 3070 versus the 2080 Ti, and I think the 2080 Ti was just a bit better. But maybe now the 3070 is better than the 2080 Ti because of just, mature drivers. It all depends.
Of course, is not perfect for AI. And so the thing that we would like to do is we would like to have in the future, your AI basically become your AI assistant. And instead of just the 3D APIs and the sound APIs and the video APIs, you would have generative APIs for 3D, and generative APIs for language, and generative AI for sound, and so on and so forth. And we need a system that makes that possible while leveraging the massive investment that's in the cloud. There's no way that the world can create yet another way of programming AI models. It's just not going to happen. And so if we could figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2. Windows WSL2 basically is two operating systems within one. It works perfectly. It's developed for developers, and it's developed so that you can have access to bare metal. It's been WSL2
interesting.
has been optimized.
Subsystem for Linux.
For cloud-native applications. It is optimized for, and very importantly, it's been optimized for CUDA. And so WSL2 supports CUDA perfectly out of the box. As a result, everything that I showed you with NVIDIA NIMs, NVIDIA NeMo, the blueprints that we developed that are going to be up in ai.nvidia.com, so long as the computer fits it, so long as you
can you find
and we're going to have many models that fit.
I guess NVIDIA's website updated. Can you go fetch that link? The Nightbot gave
digital human models, all kinds of different types of models
finally gave in a warning.
PC, and you download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live. And so this is an incredible thing for engineers and developers everywhere. Let me show you something that we can do with that. This is one of the examples of a
Okay, we'll look at that after.
Generative AI synthesizes amazing images from simple text prompts. Yet image composition can be challenging to control using only words. With NVIDIA NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene. They start by laying out 3D assets created by hand or generated with AI. Then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt. Assisted by generative AI and NVIDIA NIM, an artist can quickly realize their vision.
NVIDIA AI for your PCs. Hundreds of millions of PCs in the world with Windows, and so we could get them ready for AI. OEMs, all the PC OEMs we work with, just basically all of the world's leading PC OEMs, are going to get their PCs ready for this stack. And so AI PCs are coming to a home near you. Linux is good. Okay, let's talk about physical AI. Speaking of Linux, let's talk about physical AI.
All right, we'll look at it. This keynote still has roughly 25 minutes left.
Imagine, whereas your large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could have hundreds of thousands of tokens, and the computational load increases quadratically. And it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective, computationally demanding. What if instead of PDFs, it's your surrounding? And what if instead of the prompt, a question, it's a request? Go over there and pick up that, that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. And the technology is right around the corner. But what we need to do is we need to create the effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. If you drop something, it falls to the ground. If you poke at it, it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create we need a world foundation model. Today we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance, even across multi-sensor views. Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
NVIDIA Cosmos. NVIDIA Cosmos. NVIDIA Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things, things that are fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. And with this physical AI, there are many downstream things that we could do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. You could, because this model understands the physical world, of course, you saw a whole bunch of images generated. This model understanding the physical world, it also could do, of course, captioning. And so it could take videos, caption it incredibly well, and that captioning and the video could be used to train large language models, multimodality large language models. And so you could use this technology to use this foundation model to train robots, as well as large language models. And so this is the NVIDIA Cosmos. The platform has an autoregressive model for real-time applications, has diffusion model for very high-quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end-to-end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available on GitHub. We hope that this moment, and there's a small, medium, large for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos World Foundation model being open, we really hope will do for the world of robotics and industrial AI what Llama 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse, and the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principled physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application, the use cases are really quite exciting. And of course, for robotics, for industrial applications, it is very, very clear. This Cosmos plus Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. Every robotics company will ultimately have to build 3 computers.
Hope they can back up the claim on the 5070. I mean, it's probably going to be roughly there.
You need 3 fundamental computers.
They might stretch the truth a little bit. We'll see.
The AI. We call it the DGX computer to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium, or whatever it is. These computers are at the edge and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. And so it's the digital twin of the AI. These 3 computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this 3-computer system. instead of a three body problem, we have a 3 computer solution. And so it's the NVIDIA robotics. So let me give you 3 examples. All right, so the first example is how we apply all of this to industrial digitalization. There are millions of factories, hundreds of thousands of warehouses. That's basically is the backbone of a $50 trillion manufacturing industry. All of that has to become software defined. All of it has to have automation in the future. And all of it will be infused with robotics. Well, we're partnering with Keynote, the world's leading warehouse automation solutions provider, and Accenture, the world's largest professional services provider, and they have a big focus in digital manufacturing. And we're working together to create something that's really special. And I'll show you that in a second. But our go-to-market is essentially the same as all of the other software platforms and all the technology platforms that we have through the developers and ecosystem partners. And we have just a growing number of ecosystem partners connecting to Omniverse. And the reason for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP. So let's take a look at that, this one example that we're doing with Keynote and Accenture.
Keynote, the supply chain solution company, Accenture, a global leader in professional services, and NVIDIA are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Keynote is adopting Mega, an NVIDIA Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Keynote's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their Omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations and
oh no, you gotta update that.
The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, Keynote can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with NVIDIA, Keynote and Accenture are reinventing industrial autonomy.
In the future, that's incredible. Everything is in simulation. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and you pick, then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The next example, autonomous vehicles. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. Well, our offering to this industry is the 3 computers, the training systems to train the AIs, the simulation systems, and the synthetic data generation systems, Omniverse and now Cosmos, and also the computer that's inside the car. Each car company might work with us in a different way, use 1 or 2 or 3 of the computers.
Does NVIDIA limit how many GPUs you can buy in one sale? They
They
probably will, because there's gonna be an overflow.
EV company in the world, JLR's got a really cool car coming. Mercedes,
like demand's gonna be so high for them.
Starting this year.
Relative
And
to
I'm
the supply.
super pleased to announce
This
that
happens
today,
every time.
Toyota and NVIDIA are going to partner together to create their next generation AVs. Just so many cool companies. Lucid and Rivian and Xiaomi and, of course, Volvo. Just so many different companies. Wabi.
But I'll explain a few things after this. Some of it's not like even necessarily public data as to what direction I feel like it's gonna go towards with the GPU market.
Vehicles on the road all over the world, 1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or, fully autonomous coming up. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. This business for us, notice in just a few of these cars that are starting to ramp into the world, our business is already $4 billion, and this year probably on a run rate about $5 billion. So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car, is called Thor. I have one right here. Hang on a second. Okay, this is Thor. This is Thor. This is a robotics computer. This is a robotics computer. It takes sensors and just a madness amount of sensor information, process it, umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a humanoid robot, it could be the brain, it could be the manipulator. This processor basically is a universal robotics computer. The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. The only and the highest. And so I'm really proud of this. ASIL D, ISO 26262. It is the work of some 15,000 engineering years. This is just extraordinary work. And as a result of that, CUDA is now a functional, safe computer. And so if you're building a robot, NVIDIA CUDA, yeah. Okay, so now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars. And today, instead of showing you a whole bunch of videos of cars driving on the road, I'll show you some of that too. But I want to show you how we use the car to reconstruct digital twins automatically using AI and use that capability to train future AI models. Okay, let's play it.
I'm kind of quiet about this part. It's just I'm pretty focused on it.
Autonomous vehicle revolution is
but we'll go over a few things here soon.
Building autonomous vehicles, like all robots, requires 3 computers. NVIDIA DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous
What's up, Tempo?
means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by NVIDIA Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes. The Omniverse scenarios are used to condition Cosmos to generate massive amounts of photorealistic data, reducing the sim-to-real gap. And with text prompts, generate near infinite variations of the driving scenario. With Cosmos Nemotron Video Search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. NVIDIA's AI Data Factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
Isn't that incredible? We take thousands of drives and turn them into billions of miles. We are going to have mountains of training data for autonomous vehicles. Of course, we still need actual cars on the road. Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability so that we generate data for training AIs that are physically grounded and accurate and or plausible so that we could have an enormous amount of data to train with. The AV industry is here. This is an incredibly exciting time, super excited about the next several years. I think you're going to see, just as computer graphics was revolutionized such incredible pace, you're going to see the pace of AV development increasing tremendously over the next several years. I think the next part is robotics. So
oh, here we go.
humanoid robots. My friends.
All right, guys, meet your future nannies and housekeepers right here.
The ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots, and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars. And the reason for that is we spent 100+ years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. And so we think that the robotics era is just around the corner, the critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and Omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. NVIDIA Isaac GR00T helps tackle these challenges, providing humanoid robot developers with 4 things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large data sets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos Multiverse Simulation Engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by NVIDIA Isaac GR00T.
We're going to have mountains of data to train robots with. NVIDIA Isaac GR00T. NVIDIA Isaac GR00T. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. And, well, I have one more thing that I want to show you. None of this would be possible if not for this incredible project that we started about a decade ago. Inside the company was called Project Digits, Deep Learning GPU Intelligence Training System. Digits. Well, before we launched it, I shrunk it to DGX and to harmonize it with RTX, AGX, OVX, and all of the other X's that we have in the company. And it really revolutionized, DGX1 really revolutionized, where's DGX1? DGX1 revolutionized artificial intelligence. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility, and you have to go build your own infrastructure and really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, And Elon was there, and Ilya Sutskever was there, and many of the NVIDIA engineers were there, and we celebrated the arrival of DGX-1, and obviously it revolutionized artificial intelligence and computing. But now artificial intelligence is everywhere. It's not just in researchers and startup labs. You know, we want artificial intelligence, as I mentioned in the beginning of our talk. This is now the new way of doing computing. This is the new way of doing software. Every software engineer, every creative artist, everybody who uses computers today as a tool will need a AI. And so I just wish that DGX-1 was smaller.
Weird cut there.
You know, you know, imagine, ladies and gentlemen, this is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or, you know, connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside. It's just so cute. And this is the chip that's inside. It is in production. This top secret chip we did in collaboration. The CPU, the Grace CPU, is built for NVIDIA.
Roger's like, I'm so sick of this AI.
They're the world's leading SoC company, and they worked with us to build this CPU SoC. And connect it with chip-to-chip.
It's one of their small AI computers.
And this little thing here is in full production. We're expecting this computer to be available around May timeframe. And so it's coming at you. It's just incredible what we could do. And it's just, I think I was trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like. You know, who doesn't want one of those? And if you use PC, Mac, you know, anything, because you know it's a cloud platform. It's a cloud computing platform that sits on your desk. You could also use it as a Linux workstation if you like. If you would like to have double digits, this is what it looks like. You know. And you connect it together with ConnectX, and it has Nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits.
Interesting. The name of the keyboard and the mouse from last night. I'll have to pull it up.
Well, let me tell you what I told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. One amazing AI world foundation model, the world's first physical AI foundation model. It's open, available to activate the world's industries. of robotics and such, and three robots working on agentic AI, humanoid robots, and self-driving cars. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. I made you a short video to reflect on last year and look forward to the next year. Play, please.
All right, looks like this is coming to a close.
Have a great CES, everybody. Happy New Year. Thank you.
All right, looks like that's coming to a close. So yeah, I mean, like, I'm pretty sure most of you are probably interested in the graphics cards right now. So we're gonna go over a few things. There's obviously a few things that are pretty telling. Let me go ahead and let me pull up the link that was sent here, and this is the RTX 50 series. So they didn't give an exact date in the keynote as to when this is coming out. It's kind of interesting how they're really flexing the back of the card rather than the side with the fans. Usually it's the other way around. Carson, I know you were wondering a few things and concerns to like supply and what's going to be happening with the 4000 series. There's a few things I do want to go over, and that's going to be in respect to, I'm very interested in seeing the amount of memory that is in here, because the amount of memory in here is actually going to be a very telling tale as to what type of production you're looking at. Because usually, you know, it's not like NVIDIA makes every single component that is in this card as with every single other computer manufacturer in the world, they don't 100% make every single component in their products. Apple does not make 100% of the components in their iPhone. NVIDIA does not make 100% of the components in their graphics card. So there will be kind of like their bottleneck. And to give you guys an idea, we do work with companies that supply NVIDIA specifically with their RAM, which is Micron. Now it uses a new type of VRAM known as GDDR7. The thing is that that's new. It's probably not up to scale, and I know that Micron has been kind of at capacity because SSDs that use like Micron RAM and Micron NAND, they're just up in price significantly. And part of the reason is because NVIDIA has been pretty much buying all of the components from Micron. So they've been at high capacity. And I think the keynote kind of gives you an idea of where NVIDIA is placing its importance on the 50 series of graphics cards and gamers. It's pretty down here while AI is up here, like they didn't even go into really any details about the 50 series. They didn't say how much NAND it has. They didn't go into any performance tests or anything like that. So it was mostly just AI. So here they got kind of like some benchmarks to show. So let's go ahead and let's look at the 5070. So with RT, they're saying the 5070 that looks like 2.25 or 1.25, 1.3. This is close to 2, 2.2, 2.3, something like that. So this is 4070 versus 5070. And then right here they have 5090 and 4090. I kind of wish they showed a comparison here of the 5070 versus the 4090. But I think that their bottleneck is going to be basically their VRAM. And you saw how much VRAM those chips came out. Not the 5000 series, but specifically we're talking about like their AI chips. They're definitely putting Micron at capacity. And do you think that they're prioritizing using that VRAM towards throwing it into 50 series cards? Probably not. They're probably going to be throwing it into their other Blackwell like server chips, AI chips, everything like that for learning models. So my expectation is that they probably will sell out. So I wouldn't go and rush to sell your graphics card or anything if you have like a 30 series or a 40 series. If anything, if you're looking for an upgrade, it's probably a good time to buy, because people are gonna see this and they're gonna panic. They're gonna be like, "What, the 4090 that I bought for like, 1700 bucks is now gonna be a less power efficient 5070 for 550, and they're going to go and they're going to dump their graphics cards like their 4090s. They could end up dumping them on eBay for like 500 bucks only for release day to come. It sells out over the course of a few days, and then now there's no 50 series cards on the market and they got to go back. Oh no, there's 4 ads. Unfortunate. But yeah, that's the thing right now, is that that's what I would recommend, is that people are probably going to go panic dump their 30 and 40 series graphics cards right now. Um, and you guys can kind of go and capitalize on that if you're looking for a cheap upgrade. Like if you're if you have like a 3070 and you really want a 4080, uh go buy a 4080. The 50 series will come out. It probably will sell out. Prices will go back up, and then you can go ahead and sell your 3070 for probably a similar amount. I would not be surprised if people started to, because I remember this happened with the 20 series of graphics cards when the 30 series came out. The 30 series was coming out and people were like I think that the claim they were making was that the 3080 had twice the performance as the 2080 Ti. The 2080 Ti was going for $1,200. Everything was in demand. And then they said 3080 is going to be twice as good as the 2080 Ti at $700. People, I literally saw graphics cards, 2080 Ti's go from like $1,200 a card, $1,100 a card, to I saw them selling for like 400, 450 on eBay. They were going absolutely crazy. And I think that the same thing might repeat. Uh, so, I would look, if you were interested in a 40 series card, if you're interested in the 50 series card, that might be a tough grab. But if you were just interested in a 40 series card, it's probably going to be better to buy a 40 series card in the next few days than it is to buy it in like a few weeks after 50 series launch. That's just like a potential. But also it will depend on like the coverage that people are having, but you can expect there's probably going to be a big dip in the graphics card market until the 50 series launches. So go ahead, take a look at what deals there are and go grab something. You honestly don't trust their claims that the 50 series on the 50 series below the 5080? I mean, we can speculate. We don't know, but the thing is that even though they've stretched the truth a bit, because come on, they're going to do that. For the most part, they have not been necessarily wrong before in those claims. So, if we're going to get a bit of an idea, just let's think about like what a 4070 brings, right? Yeah, you can probably expect that the 5070 will probably be near 59 or a 4090 performance. But I think that's going to be something that's just we're gonna have to wait for some reviews and other things like that. Let's go ahead and let's look at the specs here. So if we look here, all right, so 5070 starts at 12 gigs of VRAM, and then 16 for the 5070 Ti, as well as the 5080, and then 5090 32 gigs, kind of like what the rumors were expecting. One of the things is that this is GDDR7, so it's new. It's not necessarily onto full scale production like GDDR6 or GDDR6X would be. So this will be limited, and if you think that they're going to be using their limited supply on 50 series cards, that's probably not going to be the case. All right. I got old cards just sitting around, GTX 1080, 1060, and 3060 I'm currently using. I mean, like, if we're talking about like older series, like 10 series, there probably isn't going to be a massive effect on them. Maybe on the 3060 a little bit. So I'm assuming that the 5080 Ti or 5080 Super will have 20 or 24 gigs of VRAM. It might. I mean, that's probably going to be a ways down. You know how NVIDIA likes to work those things later on. Supers kind of come out late into the card's lifespan, so we can only assume it might be that case. Nine months to a year, probably longer than that. More like 15 months. I don't know. We can go ahead and we can kind of dive in. Let's see if anyone's panic selling right now, you know? There might be a few people, but I don't know if that will be the case just yet. You know, they might wake up to this news tomorrow and start panic selling. So let's see what's going to be newly listed. All right, doesn't seem like there's any panic selling going on just yet. Kind of taking a look at this. So right now it seems like everything seems to be the same. And it could also be partially because they stopped production a while back. We'll see. But the big thing, you know, most of these people, they don't watch the keynote. The vast majority, they're pretty much like what's the word? They watch it break in the morning. You're glad you didn't jump on the 3090 the other day for 500 then? I wonder what that would go to. I still got a 3090 in that system over there. Then I got a 3070 right here, 4080 right here. You're gonna assume no less than 400? I mean, you never know. I mean, like, I literally watched 2080 Ti's drop $800 overnight before. I'm worried I'm gonna have trouble selling my 4070 now. You'll probably have trouble selling it this month. If it does end up like selling out, if the 50 series ends up selling out, then you shouldn't have any trouble in February. Prices would go right back up. But I don't know. If you guys saw, let's say you guys saw 4090s going for even $700 on eBay, would you jump on that? Or would you not risk it thinking that maybe you jump on that? I'd jump on that. I would jump on it. Because we just don't know as far as you know, the supply, but I'm assuming that the supply is going to be limited because I have tried to look into working with, would you take that deal? I'd take that deal. Yeah, found 4090 for 1300 14 minutes ago on Facebook Marketplace, and I bet you that some people are going to be undercutting that. What's it called? Because here's the thing, right? Is that for like SSDs, there's some SSDs that we want to bring to market, but the problem is that for the specifics behind them, we wanted to go with Micron, and Micron is just so hammered right now because you have to bid against NVIDIA right now to be able to get Micron. Which tells me that Micron is at capacity and NVIDIA is not going to prioritize 50 series cards. But I don't know. Ezio, what were you looking to upgrade to? You were upgrading. You wanted to upgrade to a 4090, correct? Bought used 3070 for 200 back in November. Went in a nice build. Yeah, you can. That's a pretty good deal for a 3070, to be honest. Uh, yeah, I think I picked this one up for uh probably like 240. Um, but as far as I was kind of laughing at the entire time that Roger was like bawling his eyes out. He's like, "Please, I just wanted to see the release of the 40 series. No more AI, no more AI." I mean, like, it really does tell you the priority, where NVIDIA is placing the priorities. Um, of course, you don't realize how important it is to actually improving performance on games. I mean, like, DLSS is so good that you can't tell the difference between, like, it's extremely hard to tell the difference between like a full rasterized rendered frame and one that's upscaled with DLSS, and it literally doubles your FPS plus. Roger's just upset about this. AI is most of their market share. Let's think about it like this, right? If they were not getting into AI, their market share would be so down from what it would be right now. Because let's not forget, 10 years ago, AI, NVIDIA's market cap was $10 billion, like $15 billion. That is nothing compared to what it is now. It is literally like 400x. Yeah, AI more. Yeah. So, um, and even like during the whole crypto boom, uh, it it didn't even reach 100 billion. I mean, like 2 years ago, what was it? Like 500 billion? 2.5 years ago? So I don't know. We'll see. We'll see. Uh, I do like the oh, crypto miners ruin the GPU market. It's pretty funny because there's a time back in like 2017 where the 1070, the GTX 1070 was going for like um $700. And there's this guy, I met him to pick up a 1070, and he was a guy, he didn't have it listed anywhere. He's just a guy that I had picked up parts from before. I asked him if he had anything, and he had one for 250. And I was like, "Yeah, I'm going to buy that." And then I was curious if I listed it on like Craigslist, just like a fake listing, just to see what kind of response it would get for the same price. Dude, my email, because at the time I was in New York, my email blew up so hard. Uh, and it just blows my mind that like people were just like going crazy trying to get, like, they were buying 1070s for $700. That's ridiculous. But yeah, I don't know. We'll see. we'll see what turn the market takes. But yeah, I think that's pretty much is PNY 4090 for 1550 in my area a good deal. I mean, it's lower than, I mean, like let's look at some of these prices before they update here real quick, because this one was just listed $1,500 for a founder's edition, brand new sealed. Usually, if I'm not mistaken, right now 4090s, like over the past month, because there's been no production, the supply is low, so and demand is up, so the prices should be higher. I think people were selling 4090s for literally $2,300. Let's see here. Here's another 4090, 1900, and these are pre-owned. 2600, 2300. It looks like a lot of people were selling their 4090s for over $2,000 because there was low supply. And literally just like the most recent one all of a sudden is undercutting these guys by like $700. So, but here's the thing. Yeah, I think that you'll see tomorrow prices will go down. I don't know, let's refresh the page. Let's see if anyone else is gonna be panic selling. Right now, I mean, like here already, we're starting to see people list their card, and everyone else was listing it, $2,300, $2,600, $2,300. This was an outlier right here, 1850. Maybe he was just trying to sneak it out before the keynote got out. Yeah, here's one for almost $2,000, and all of a sudden, we instantly are starting to see, like, that's a good amount of just from like the small time that we've been talking. That's a good amount that just got listed just now, and they're taking bids or buy it now 1,700. I mean, they're undercutting by 600 just with this buy it now. 1,900. Still, this guy wants to grab 2,000. But instantly, we saw a couple listed, and the prices have already gone down. I would say like $500 just since the keynote ended. And this will probably kind of snowball even harder into a panic dump. So you've seen 4080 Supers going for like 1,300. Yeah, it makes sense. Mustafa, what's up? What's up? Welcome to the stream. You're kind of late. The keynote's over. We're just going over some of the 50 series here. Someone in my local PC group says, I'm buying all the 4090s for 600 a pop. Go buy yourself a 5070. Yeah, that's probably what some people are gonna do. I think some people are gonna, you know, just see this and panic, and then there's some people that are gonna read deeper into it. I don't know. Ezio, what are you gonna pick up if you see something good? Like, what is a 4090 price? Because I think you were talking about getting a 4090. What is a 4090 price that you would be like, I would buy that right now? And Red Cat, I think you were talking about that as well. Oh yeah, and let's go ahead and let's compare this to the 4090 here. $2 and a lollipop. Okay, he says 850-ish, 900. Okay. Yeah, no, I think that's pretty good. I wouldn't doubt if for a few days it goes under 1,000. So AI tops. This is here we go, 4090. Let me go ahead and let me make this a little bigger for you guys. Yeah, a little bit smaller. Okay, so let's look at the they don't have listed here CUDA cores. Weird. But I guess we can look at AI tops. So here we got 1321 5070 988. So seems like a little bit low compared to the 4090, which they're saying is, you know, relatively like they're relative to each other. We'll see. I mean, like AI tops isn't everything, you know. And then we see here 5070 Ti 1406, so significantly more than the 5070. Comes with those extra 4 gigs of VRAM. And then right here we see the 5080 1801, and then a massive leap with the 5090 to 3352. Okay, so let's see. I'm gonna wait for the 50 series to drop though. I want to see what design companies go with. I want to look at performance. I see a Gigabyte 4090 for $1,400. Yeah. People are gonna be dumping them. I'm almost certain about that. I don't want to forecast because then I might jinx myself, but I'm already too deep, so. Let's see here. So there's the encoders, memory bandwidth. All right, well, I'd say MSI Gaming X Trio. Oh yeah, I mean, like I had one in that system over there when I had a 2080 in there. I've got one right here for the 4080 right here. Gaming X Trio, cool design, runs well, runs cool. I recommend it. So, oh, I see. Okay, so you see someone's listed their Gaming X Trio for 1100 just now. That's a 4090. Am I correct on that? Is that an MSI Gaming X Trio 4090 for 1100? Just listed, but it's 10 hours away. Yeah. I wonder if there's any more listings that popped up on okay, so look right here. Someone's already panic dumping. We have 1350 right here. 1800 right here, but this person's definitely panic dumping. They're like yeah, okay, in New Jersey. I wonder where this guy's at. He is in Florida. So he is panic dumping his 4090 right now. Gigabyte Aero 4090 or 2000 here in Algeria? Well, keep an eye out because then you might have some locals that are selling their graphics cards for super cheap. Keep an eye out for people just trying to sell the heatsink, though. Keep an eye out for people who are selling both the card and the heatsink, but then when you open the card, there's literally no GPU die on there. They will do that. They'll take like a 4090 that's cracked, take the GPU die off of it, throw it into a 4090 where the die is not working, and then just try and sell you the garbage. Someone just listed both of their kidneys for $1,100. What a deal. Well, why aren't you jumping on it then? Oh no, let's see. No more right now. I have this set to newly listed. I wonder what's going on with 4080s. Okay. So let me go ahead and look right here. So it seems like, right? Earlier, a lot of people were selling their 4080s, 1300, 1500, 1450. This person was selling it 900. That's kind of ridiculous. It seems like it's been up for a bit. Maybe there's some sort of issues because it already has 13 watchers and people haven't jumped on it yet. 1400, 1650, etc. And then we see 1200 and all of a sudden 1100. Okay, so let's see. And then out of the blue, we have right here 930, 980, 910. Yeah, be sure to look out for fake listings though. All right, Red Cat, you got to head out. All right. Take care. Thanks for sticking through the entire stream, man. Appreciate it. Hmm. All right, see, someone's already oh no, this is still a 4080 right here, 4080 Super. All right, but right now, yeah, prices are down. This person just listed theirs. They have it up for starting bid $600 and then 1800, which is obviously 500 down from what it was, 600 down from what it was going for like an hour ago. I'm curious to see what happens overnight. You really want to get your hands on a Threadripper to mess around, a 32 core one? Yeah, I mean, like, depends what you're gonna use it for. I feel like there's very specific use cases where you're gonna use that. But all right, guys, we're gonna go ahead and we're gonna wrap it up. I think that's really all we're gonna cover right now. But yeah, just keep an eye out for prices. That's just my suggestion. But all right, guys,